previous lecture, and I gave you a few questions to think upon. So the first question, as in front of you, we wanted to know what would this particular region geometrically represent. Okay, so let's say if Z belongs to all those complex numbers such that argument of Z minus of pi by 2 modulus is less than pi by 2. So we want to know what would this particular region tell us about. Okay, so what would this region tell us about? That we need to see. Okay, so how would we think about, how should we think about it? It does imply what? It implies that argument of Z must be between pi and 0. So if you solve this particular equation, that is argument of Z minus pi by 2 modulus being less than pi by 2, what does it imply? It implies that argument of Z minus of pi by 2 is less than pi by 2 and it is greater than minus pi by 2. And you can supply plus pi by 2 on both sides and you can get that argument of Z has to be between 0 and pi. If argument of Z is between 0 and pi, what does it imply? It implies that we are talking of this region. What is this region? This region is that region where your y is greater than 0. That is, you're talking of all those complex numbers whose imaginary part is greater than 0. So whether you write this way or you write this way, this is one and the same thing. So this particular region is nothing but it is the upper half of the complex plane. It is nothing but it is equals to the upper half of the complex plane. Upper half of the complex plane. Okay, so this is one important thing that I wanted to tell you. See, whatever we are doing till now, and probably I'll try to conclude in today's lecture most of the complex number part, like theoretical part, you can practice a few more questions from SHOM series. I would recommend SHOM series for practicing questions because it has got a good amount of unsolved and solved both. So basically, if you solve those exercises, on the similar pattern, you'll find unsolved example. So SHOM series can be one of the very good source for independent learning. Okay, so if you want to independently learn, then that is a very good book. For theory, as I've already mentioned, you can take any of the books like S. Ponuswamy, you can take S.S. Kasana and other books for Indian authors. And if you want to take from foreign authors, you can take Churchill and books like other like that. But the point is this, most of the text that I'm covering in these lectures is from S. Ponuswamy and Churchill. So basically, I'm covering both of them. So possibly after going through all these lectures, you may then revisit the books, and then you will find that you are at a much relative. You're at a relatively. You will find them relatively easy to follow. Okay, so this is just a general advice. Now let us move to a few more portions that I gave you, a few more questions that I gave you. In the previous lecture, I also told you that if suppose Z1 and Z2 are two non-zero complex numbers, then the condition Z1, Z2 bar plus Z1 bar Z2 equal to 0. What does it imply? What does this condition imply? So I'm giving a title to this particular condition as, okay, just give me a minute. So this gives you the condition for perpendicularity. My bad, I think this is, okay. So this gives you the condition for perpendicularity. Now let us see how. Let us see how. Okay, so suppose that Z1 and Z2 are two non-zero complex numbers. These are two non-zero complex numbers. Z1 and Z2 are two non-zero complex numbers. And it has been given to you that Z1, Z2 bar plus Z1 bar Z2 is equal to what? 0. Okay, it has already been given. That is, we already know. It implies what? It implies that whether you write this way or you write, this can be possible if and only if Z1 upon Z1 bar, or you can say Z1 upon Z1 conjugate is equals to negative of Z2 upon Z2 conjugate. And what you can do, simply you can multiply Z1 both sides. So you'll get Z1 square divided by Z1 mod whole square, and it is equals to minus of Z2 square divided by Z2 mod whole square. Now what you can do, you can use some polar representation. So I can use Z1 is equal to R1 e ki power iota theta 1, and Z2 is equal to what? Z2 is equal to R2 e ki power iota theta 2. If I use this, and I know that what would be mod Z, so a mod Z1 would be simply R1, and what would be mod Z2? It will be simply R2. And if I square it up and so things like that, I'll simply get e की power iota. I'll get 2 here. I'll write 2 theta 1 and I'll write e की power 2 and negative also 2 iota theta 2. And always remember, minus 1 can always be written as e की power iota pi. Okay. So I can always write this way. So it will give me e की power iota theta 1. And in fact, you can write this as e की power iota pi plus 2 times theta 2. Always remember, whenever you're going to compare these two arguments, so for example, if you have e की power iota z1, sorry, theta 1 here, and if you have e की power iota theta 2, then theta 1 equals to theta 2 is fine. But another most general solution would be theta 1 is equal to theta 2 plus 2n pi. So if you, or 2k pi, whatever you wish like writing. So always remember that if e की power iota theta 1 is equal to e की power iota theta 2, this is fine. But more general solution would be this. So the more general solution from here, I can write it as e की power iota theta 1 is equals to iota pi plus 2 theta 2 plus sorry, I should write here itself. So I can write here itself. I'll write 2n pi. Okay, so that you don't get confused. So in order to write more general way of writing would be, so iota gets cancelled. So I will simply write 2 theta 1 is equal to pi plus 2 theta 2 plus 2k pi. Or I'm writing k here, 2k pi where k belongs to z. So what do you get? You get that 2 times argument of z1 is equals to 2k plus 1 pi, and then you have plus 2 times argument of z2. What is theta 2? Argument of z2. Now you divide it, you get argument of z1 is equals to argument of z2 plus 2k plus 1 times pi upon 2. So what do you get? You simply get that argument of z1 minus argument of z2 is nothing but multiples of pi by 2. And in fact, this is odd and even multiple. Odd multiple only, even doesn't exist. So it gives you multiples of pi by 2 such that pi by 2 remains intact. That is, it gives you sort of, you can write that basically it implies that the angle difference, that is the argument difference between z1 and z2 is some multiples of pi by 2 and odd multiples of pi by 2. Okay, not even. So even would give you what? If it is 4, then it will give you pi. So it's not multiple of pi, it's multiples of pi by 2 such that pi by 2 structure remains intact. That is, you can say that these angle between z1 and z2, angle between z1 and z2, if you express them vectorially, is 90 degrees. So here you can say that if we express z1 and z2 vectorially, then vectorially you can say that z1 and z2 are perpendicular to each other. Are perpendicular to each other. This is something that you should remember. Okay, so what does it imply? So it implies that whenever z1 and z2 are perpendicular to each other, and remember all these conditions are what? These are if and only if condition, because if this is true, then this is true, and if this is true, then this is true. So all these are conditions are if and only if condition. Okay. So it implies z1 and z2 are perpendicular to each other if and only if z1 z2 bar plus z1 bar z2 is equal to 0, or I can say that real part of z1 bar z2 is equal to 0. So if real part of z1 bar into z2 is equal to 0, then it implies that z1 and z2 are what you can say perpendicular to each other. In fact, you should remember that if real part of z1 bar z2 is 0, then it implies that it will be purely imaginary. So it implies that z1 bar into z2 can be written equal into some e की power iota, let's say t or something. Okay, and that does imply that z1 bar is equal to iota t divided by z2, and you can multiply on both ends by something, let's say by conjugate, and again take conjugate of it. So minus iota theta 2 upon z2 conjugate, and you can simply then do some mathematics here, you can write that Z1 would be equals to iota times some constant, let's say S here. If I just multiply by Z2 up and below, so you can express your one of the Z1. So you can express one of the complex number as iota S times other complex number. So basically this helps a lot. So one has to remember that if this is the condition given, if this is the condition given to you, so the first question I've already solved. This first question has been solved. Second question, remember that if Z1 and Z2 are two non-zero complex numbers, and the condition given to you is Z1 into Z2 bar plus Z1 bar into Z2 equal to 0, it implies that it, it implies that Z1 and Z2 are perpendicular to each other. So this condition, if it is given to you, it implies that Z1 and Z2 are perpendicular to each other. And in fact, now the next condition, this condition will, you will be able to know, I'm going to solve it further. It is going to be the condition for the parallelism. It is going to give you it is going to give you the condition for the parallelism. Okay. Now see what you are given. So let's say, let Z1 and Z2, let Z1 and Z2 be two non-zero complex numbers, be two non-zero complex numbers. Be two non-zero complex numbers. And if this is the condition given to you, that is Z1 bar into Z2 minus Z1 into Z2 bar is equal to 0, then what does it imply? What does it imply? So see, these are very standard questions, so don't worry about it. You can find all these solutions in the books. Any of the standard textbooks you'll find. So this is something that these questions I'm giving from standard 11 to something. But just to make you a little bit acquainted with complex numbers. So today is the last turn. From tomorrow we are going to start with topology anyway. I thought that today we would be able to start, but probably we'll start tomorrow. But see, if Z1 bar into Z2 minus Z1 into Z2 bar is given to be equal to 0, what I can write? I can write that Z1 upon Z1 bar is equal to Z2 upon Z2 bar, and which implies that Z1 square upon Z1 bar, Z1 mod whole square is equal to Z2 square upon Z2 mod whole square. Simply I have multiplied by Z2 below and above, and which necessarily implies, if I write that Z1 is equal to R1 e की power iota theta 1, and if I write Z2 is equal to R2 e की power iota theta 2, what does it give me? It gives me R1 square divided by R1 square e की power 2 iota theta 1, and it is equals to R2 square upon R2 square e की power 2 iota theta 2. See, as I told you before also, if I am writing the general solutions, if it is given that e की power iota theta 1 equal to e की power iota theta 2, it implies that theta 1 equal to theta 2. I have no issues about it. But more generally, you can write that theta 1 is equals to theta 2 plus 2n pi. It is the more general solution. Remember, okay, this is the general solution because because you know that e की power iota 2n pi expresses what? It is equal to 1. So here, in fact, you can write it as equal into 1, and then you can write e की power iota 2n pi, or otherwise you can understand by periodicity consideration also, this can be understood. So if I'm writing e की power iota theta 1 is equal to e की power 2 iota theta 2, what does it imply? It implies that 2 iota theta 1 is equals to 2 iota theta 2 plus 2n pi, and it implies that 2 times, or it implies that argument of Z1, here iota, but also argument of Z1 is equal to argument of Z2 plus n pi, where n belongs to Z. Okay, what does it imply? It implies that if you take n equal to 0, then argument of Z1 is equal to argument of Z2. or otherwise it only differs by pi. Either it is parallel or it is anti-parallel. So we can say that this means that Z1 is parallel to Z2. Z1 is parallel to Z2. And if Z1 is parallel to Z2, in other words, you can also write this entire condition as what? This particular thing can be written as what? Just thoda sa socho, this is equals to imaginary part of Z1, Z2. See, it is 2 iota imaginary part of Z1 bar Z2. So if you want to find the imaginary part of Z1 bar Z2, it is equal to what? It is equal to Z1 bar Z2 minus Z1 into Z2 bar divided by 2 iota. This is what is the imaginary part of Z1 bar Z2. And remember, this is given to be equal to 0. It implies what? Your imaginary part Z1 bar Z2 is given to be equal to 0 after all. So imaginary part equal to 0 matlab kya hua? It implies that the real, it would be what? It implies that Z1 bar into Z2 is purely real and it is equal to, let's say, K. And it implies that Z2 is equal to K times Z1 bar. And it implies what? It implies that Z2 is equal to some constant times Z1. So from here also you can understand that this implies that it implies the condition for parallelism. So if you're given in the exam Z1 bar Z2 minus Z1 Z2 bar equal to 0, it implies that Z1 and Z2, these two complex numbers are parallel to each other. I hope it is clear. So all these three questions I gave you in the last lecture. So I have solved these three questions. Now let us try to solve a few more questions or start a little bit of more understanding of complex numbers. Remember, till now, whatever has been taught is not much of the MSc syllabus. This is just to develop a little bit of understanding of you people in the domain of the complex numbers. Okay, so these are just a recap of what you've studied till now, till 11th class or 12th class. So it's not beyond that. So it's just that easy. So don't worry about all these things. See, now another important thing that you can notice that if there are 2 points, let's say zeta 1 and zeta 2, okay, and we are considering a line passing through these points. We are considering a line passing through zeta 1 and zeta 2. And we are also considering line passing through point zeta 3 and zeta 4. So line passing through zeta 3 and zeta 4. So we are considering two lines passing through zeta 1 and zeta 2 and another line passing through zeta 3 and zeta 4. What is the condition that these two lines are perpendicular to each other? What is the condition that these two lines are perpendicular to each other? So remember, I told you that the condition for perpendicularity is Z1 into Z2 bar plus Z1 bar into Z2 equal to 0, or that real part of Z1 bar Z2 is equal to 0. This is also the condition for perpendicularity. And if real part of Z1 bar Z2 equal to 0, then it implies what? One of the complex number Z1 can be written as iota S Z2. So one of the things like Z1 can be written as iota S times Z2. So basically you can write Z1 as some complex like iota S times Z2. This is the condition for perpendicularity. Okay, so this has been already discussed. So here it is. So if I'm saying that there are two lines, one line passes through zeta 1 and zeta 2, and another line passes through zeta 3 and zeta 4, what is that condition that these two lines are perpendicular to each other? So clearly, it implies that zeta 1 minus zeta 2 divided by zeta 3 minus zeta 4. This will give you the distance between the 2 points. And this is equals to what? It should be equals to some iota times S. Or other words, if I say that what would be the argument wise? So argument wise, we understand that if these are perpendicular to each other, then this is equals to pi by 2 plus minus 2k pi, or minus pi by 2 plus minus 2k pi. All those who have joined today, I think you'll have to see all these things. I've already discussed all these things. So once just go through the lecture and understand what is perpendicularity. Once you understand what is perpendicularity, then I don't think there would be an issue with this. Okay, and here K belongs to, okay, so here K belongs to set of natural number union 0. Okay, So this is, if there are two lines, one line is passing through 2 points zeta 1 and zeta 2, another line passes through zeta 3 and zeta 4, then these are perpendicular if and only if zeta 1 minus zeta 2 divided by zeta 3 minus zeta 4 is equal to iota s. Why iota s? This is from the conditions that we've already discussed. That for two complex numbers z1 and z2 to be perpendicular to each other, the real part of z1 bar z2 must be equal to 0, implies that z1 should be equal to iota s times z2. Similar conditions I've used here and I've done it. So all these things are basic complex numbers. A few more results I'm writing without proof. A few more results. See, for a given complex number, for a given complex number, z is equals to x plus iota y belongs to set of complex number. There always exists a square root, or in other words, there always exists some w square which is equal to z, and this w is given by, I'm not deriving it but I'm just writing it, this w is given by plus minus root over modulus of z plus x upon 2 and plus iota signum y times root over modulus of z minus x upon 2. Here signum, if you remember from real analysis, signum y is equal to plus 1 if y is greater than 0, and it is equal to minus 1 if y is less than 0. So for every complex number z is equal to x plus iota y, there always exists another complex number whose square is equal to this. It implies this gives you the existence of the square root. It gives you the existence of the square root of a complex number z. Okay, so I think this is a little bit. Don't memorize this solution. I'm just giving you the direct answer. How would you be able to do these things in exam? See, don't memorize this formula. See, whenever you are told to solve, you are told to find the square root of a number. So just take this as, let's say I'm saying that we want to find the square root of z. So finding square root of z is equivalent to solving this equation, w square equal to z. See, if I want to say that what would be root over z, let us say it is equal to w. It implies what? It implies that w square should be equal to what? Z, right? So if I use that w is equal to u, if I write that w is equal to u plus iota v, then w square will be equals to what? It will be equals to u square minus v square plus 2 iota uv. And from here, you can simply write that u square minus v square is equal to, is equal to x, and 2uv is equal to simply y. And from here, you can do a little bit of mathematics, and you will find that u square plus v square ka whole square is nothing but it is equals to u square minus v square ka whole square plus 4 u square v square, which will give you x square plus y square. So u square plus v square ka whole square is nothing but it is equal to x square plus y square, which is nothing but it is equals to the modulus of z. And from here it is u square plus v square is equal to what? It is equal to root over, it is equals to, uh, uh, u square plus v square ka whole square. It is equals to modulus of z. This is equation number 3, you can say. This you write it as equation number 1, and this you write it as equation number 2. And from here you can clearly find that your u is nothing but it is equal to what? See, sorry, this is mod z whole square. Okay, so your u square plus v square is nothing but it is equal to mod z. U square minus v square is nothing but it is equal to x. So from here you can write that your u square is mod z plus x upon 2. And from here you can find that u is nothing but plus minus root over modulus of z plus x upon 2. And always remember this modulus of z is what? Modulus of z is root over x square plus y square. So obviously it will always be greater than equal to modulus of x. What would be your v square? So v square would be nothing but is equal to modulus of x, modulus of z minus x upon 2, and this root over, so this you will get. And here also you'll get plus minus. Okay. Another thing that you can observe is that y can be positive as well as negative. Why? Because y is equals to what? 2uv. If v is positive, if v is positive and u is positive, then y would be positive. So if uv is positive, then y is positive. And if uv is negative, so there y would be negative. So therefore, you find that there is some, all these things, remaining thing you can find. W is what? W is the square root of z, and W is equal to what? W is equal to u plus iota v. And you've already calculated u is equal to plus minus root over modulus of z plus x upon 2. And v you've already calculated it is equals to plus minus root over mod z minus x upon 2. So all these things are written here only. Okay, so I have given you the enough hint, and this is how you can express the express what? You can express the square root of a complex number. So given a complex number z, you can always find a square root of a complex number using this expression. And basically, you don't have to remember this. This is the strategy that I have already stated. So you just remember this particular strategy, and you will be able to find square root of any complex number. I don't think there is enough other things to explain here. I think this is quite self-explanatory. You just go through this particular lecture, and then you will be able to understand all these things. I hope it is clear till now. Now, let us move to another theorem, which is called as the De Moivre's theorem. Usually, you find it in trigonometry, but I'm using it here. So basically, if m is an integer, always remember, I'm not giving the proof. If m is an integer, then e की power iota theta raised to power m is nothing but it is equal to e की power iota m theta, and which is equivalent to what? It is equal to writing that cos theta plus iota sin theta whole power m is nothing but it is equals to cos m theta plus iota sin m theta. So basically, if you raise this power m here, it comes inside this argument of cos and sine. So this particular theorem is a very celebrated theorem in classical mathematics. It is called as the De Moivre's theorem. Another thing that you need to remember is that we want to find the rational powers of a complex number. We want to find what? We want to find the rational powers of complex number. So rational power of complex numbers. So we want to find the rational powers of complex numbers. What do I want to say? What do I mean if I say that we want to find the rational powers? So we want to find that if m is any natural number, then it's fine. You've already written m. Let us say that if we want to find some fractional power of a complex number, let's say if I want to find the cube root of unity, if I want to find the cube root of unity, it implies what? It implies it is equivalent to finding z cube minus 1 equal to 0. And it is equivalent to, it implies that I have to find that z minus 1, z square plus z plus 1 equal to 0. The solution from here is 1. And solution from here is called as omega and omega square. And you know that omega is nothing but it is equals to minus 1 plus minus omega and omega square are nothing but it is equal to plus minus root over. So these are what you can say. These are one is another square of another. So this is how it is. So always remember that z cube minus 1 equal to 0 has three solutions: 1, omega, and omega square. And remember a little bit of understanding. I've already explained this in the complex analysis for physics. So you can go and study there. I have explained things in quite greater detail there. But right now I'm just going to draw it for you. What is 1? 1 is nothing but this is 1, 1 comma 0. What would be omega? Omega is minus 1 by 2. minus 1 by 2 comma root 3 by 2. And what is omega square? See, omega square, remember, omega square is literally square of omega. So it is omega whole square. You want to do it, you can do it also. So if you want to find minus 1 root 3 by 2 iota whole square, you will get what? You will get 1 upon 4. You will get minus 3 upon 4. And then you will get minus 2 iota 1 upon 2 into iota root 3 by 2. So from here you will get minus 1 upon 2 minus of root 3 by 2 iota. So which is equal to nothing but is equal to omega square. So remember omega whole square is equal to omega square. And also remember that omega square, omega cube is equal to 1, which implies omega square into omega is 1, which implies that omega square is equal to 1 upon omega. So one is reciprocal of another also. Okay, so this is like minus 1 by 2 comma minus root 3 by 2. So this is conjugate of that also. Now, if you join these three things, three points, if you join these 3 points, and if you find the distance between this point 1 comma 0 and minus 1 by 2 comma root 3 by 2, 1 comma 0 and minus 1 by 2 comma minus root 3 by 2, and distance here, you'll find that all these distances are same. And what you'll find that this particular, all the 3 points which represents the cube root of the unity, all these points are nothing but the solutions for z cube equal to 1. So these 3 solutions, that is 1 comma 0, minus 1 by 2 comma root 3 by 2, minus 1 by 2 comma minus root 3 by 2, which represent the cube root of unity, lie on the vertex of the equilateral triangle. All of them lie on the vertex of equilateral triangle. And in fact, all these points also lie on this unit circle, because you can clearly see that for all these points mod z equal to 1. See, 1 comma 0 mod z would be 1, minus 1 by 2 comma root 3 by 2 mod z would be 1, minus 1 by 2 comma minus root 3 by 2 mod z would be equal to 1. So all these 3 points always lie on the unit circle, and in fact they also lie on the tip of a vertex, they also lie on the vertex of the equilateral triangle. Similarly, if you extend it to 4th dimension, then also, in fact, this particular equilateral triangle, instead of equilateral triangle, you'll find a square kind of construction. So if I want to find the power 4 of unity, so you will find that this is how it lies. So if I want to find z raised to power 4 equal to 1, sorry, z raised to power 1 by 4 equal to 1, it implies that I want to find, I want to find all the complex number corresponding to 1 raised to power 1 by 4. It implies z ki power 4 minus 1 equal to 0. It implies z square plus 1 equal to 0 into z square minus 1 equal to 0. So the points would be 1 comma 0, 1 comma 0, minus 1 comma 0, 0 comma iota, and 0 comma minus iota. So all of them would lie on the vertex of a square. This is the 4th root of unity. Similarly, in complex number, there is a theorem which suggests that existence of the nth root of unity. Existence of nth root of unity. So given a non-zero complex number z, so if z belongs to a non-zero complex number, then w raised to power n equal to z, it will have n distinct solutions in C. Distinct solution, sorry, it will have n distinct solutions in set of complex numbers. And this would be given by, you can write z is equal to r e ki power iota theta. And in fact, you can write theta plus 2k pi more generally. So w raised to power n. So w is equal to what? It is equal to r raised to power 1 upon n. into e की power iota theta plus 2k pi whole divided by n. So you can find that for every complex number, you can find we can find another complex number such that w raised to power n equal to that particular number. Okay, so this actually denotes the nth presence of nth root or existence of nth root, and more precisely, if z is equal to 1, more precisely if z is equal to 1, then you can always comment on the nth root of unity. So if I'm talking about nth root of unity, it implies 1 raised to power 1 upon n must be equal to some z. It implies that z raised to power n minus 1 should be equal to 0. And what are the solutions for this? The solutions are 1, comma omega square dash 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 omega raised to power n minus 1. And these omegas are nothing but is equal to e की power iota 2k pi upon n. So this is how you can write these omegas. And what you're finding that all these numbers are in GP. So all these cube roots of unity are in geometric progression with the common ratio omega. Also, if you want to see that this omega mod would be equal to 1 clearly, e की power iota theta का mod is always equal to 1. Always remember this. Otherwise, you can do also e की power iota theta is what? It is equals to cos theta plus iota sin theta. So modulus of e की power iota theta would be root over cos square theta plus sin square theta. So always remember that all these points, that is the nth roots of unity, will be lying on the unit circle only. And if I join all these points, they will be forming an nth-sided regular polygon. They would be forming an nth-sided regular polygon. So this you can form on your own. I think all these things are given in the book. So you can do your on your own. So this is 1, 0. This is omega, which is equal to e की power iota 2k pi upon n. This would be omega square, which is e की power iota 4k pi upon n, and so on and so forth. So all these points would lie on the unit circle, and when joined, they are going to form an n-sided regular polygon. They're going to form an n-sided regular polygon. So if these are 4 points, or if n is equal to 4 regular polygon. So if n is equal to 4, then an 4-sided regular polygon is what? Square. So this is what we have seen above. What is a 3-sided regular polygon? It is equilateral triangle. What is a 5-sided regular polygon? It is a pentagon. So all these things you can do on your own. I hope it is clear. More of it has been, I have already taught in the previous lectures on complex analysis for physics people. So you can go there and you can see that in greater detail. Now, before we go ahead in topology, one special advice to you is that whenever you have to find regions, try to use the geometry. Try to use the geometry that you have studied so far. So regions, for example, most simple region is mod z minus z naught is equal to, let us say, R. What does it represent? It represents an equation of a circle, with radius R and center z naught, and center z naught, or you can say, let's say x naught comma y naught, whatever you wish, like say. Not just give me, I think people have joined, a few people have joined, a few people have left also. So I cannot help about that. So what you can do is try to solve this. And this will be, I think, the last question for, let's see, if not last, then second last. What region does S represent? Here S is nothing, but it is equals to Z, all those Z belongs to complex number such that Z minus A modulus plus Z plus A modulus is equal to 2 times C. I think two people have joined. Tanvi has joined and Shika has joined. What do you think this S would represent? What do you think that this region S would represent?
Ellipse.
Okay, ellipse. Good. कैसे करेंगे? How would we do it? See, the easiest way to do all these things is try to take some Z is equal to X plus iota with Y. So if I take X plus iota Y, you will get X plus iota Y minus A is equals to what? It is equals to 2C minus of X plus iota Y plus A. And certainly you will get from here X minus A plus iota Y modulus is equal to 2C minus of, I think, X plus A plus iota Y modulus. And you take square on both sides. So if I take square on both sides, this will be iota Y mod whole square, and it will be 2C whole square plus modulus of X plus A plus iota Y mod whole square. And then certainly you will get minus 4C modulus of X plus A plus iota Y. I think you can solve it. I think this would be equals to what? This will be equals to X minus A whole square. Remember, this is mod square. This is equals to 4C square, and then you will get X plus A whole square, and then you will get plus Y square. And I think this will be minus 4C modulus of X plus A plus iota Y. And from here, X square gets cancelled, A square gets cancelled. So ultimately what you will get, you will simply get C square plus, है ना, एक C square तो बचेगा ही बचेगा. X square gets cancelled with X square, A square gets cancelled with A square. This 4C square goes there, so this will become minus 4C square. This minus 2ax and plus 2ax will become minus 4ax. And this is equals to minus 4C modulus of X plus A plus iota Y. And from here also you can clearly see this is equal to C square plus AX whole square is equals to what? It is equals to C square modulus of X plus A plus iota Y whole square. And remember, this is mod Z whole square. So mod Z whole square is not equal to Z square. So this is equal to X square into X plus A whole square. And then I can write plus Y square is equals to C square plus I think AX whole square. And from here, I think you can try to solve it. And what you will get simply what I will get. चलो देखते हैं ना. C square X plus A whole square plus C square Y square is equal to C raised to power 4 plus C square 2C square AX and then plus A square X square. Okay. And if you open this also, you will get C square X square plus C square A square plus C square 2AX and then plus C square Y square is equal to C raised to power 4 2C square AX plus A square X square. So what you are getting, 2C square AX gets cancelled. And from here, you know that it is equal to C square minus A square times X square. And plus C square Y square is already there. And you can write it as plus C raised to square C square minus A square. And this implies what? It implies X square upon C square plus Y square upon C square minus A square equal to 1. It represents the equation of ellipse. It represents the equation of ellipse. Is that fine? थोड़ा सा मैथमेटिक्स है, but otherwise थोड़ा सा standard 12 का मैथमेटिक्स है, otherwise it's not a big deal. So till now we've been doing algebra on C, right? So all these things are complex analysis की बजाय you should say that this is nothing but it is complex algebra. This is nothing but we are doing some algebra on C. Is that fine till now?
Yes, sir.
Okay. Okay, so I'm leaving this lecture by a question. Try to do these questions. And then from tomorrow onwards, we are going to do topology part. So the question that I'm leaving you with is, if, and in fact, I'm going to write the answers also, so that if P and Q are two distinct points in C, then what does this represent? What does this set represent? What does this set represent? Just think about it. What does this set represent? So always remember, I've taught in the classes also that whenever this modulus sign comes, yes, indeed, modulus means root over x square plus y square in complex sense, and in real sense, it means finding the absolute value of the number. But but it is, what has happened? Okay, but you can. You can visualize this way also. See, if I'm saying that modulus of z minus p is equal to modulus of z minus q, what does it mean? Shikha, what does it mean? Physically, how would you comprehend this? I taught you that whenever so it represents whenever this sign comes, it implies distance. Okay, so this represents a distance. So what is this? It represents the distance of all those complex numbers which we are taking from P. It represents the distance of all those complex numbers which we are taking from Q. What does it imply? It implies that distance when taken from P and distance when taken from Q are equal. Is that fine? So basically, what does it imply? In English, if I want to write, it implies equidistant points from P and Q. Is that fine? It represents the equidistant point from P and Q. ये चीज समझ में आई? Is that clear or not? ठीक है. So equidistant point from P and Q मतलब क्या हुआ? Let's say this is your point P and let's say this is your point Q. So Z is somewhere here, and the distance from P, distance between Z and P, and distance between Z and Q are same. Okay, is that fine? So it implies what? It implies that if I draw here this way, so this particular thing, this particular Z will be lying on what? This will be lying on the perpendicular bisector of P and Q. Is that fine? So this is your distance Z minus P modulus, and this distance is Z minus Q modulus. And if both of them are equal, if I drop a perpendicular, this will be perpendicular bisector of the line joining P and Q. Is that fine or not fine?
Yes, sir.
Okay, so this particular set not only represents the equidistant points from P and Q, rather it represents the straight line which is the perpendicular bisector, of the line segment joining P and Q. Okay, so at times in examination you won't find you can find options written this way. मतलब समझ रहे हो? You won't find that this is they will write this and then they will ask what does it represent? What is the locus of this particular expression? So locus is nothing but it is the perpendicular bisector of the line joining the two points. Okay, is that fine? ये बात समझ में आई नहीं आई?
Yes, sir. Yes, sir.
Okay, similarly, एक मैं ऐसे लिख दे रहा हूँ so that you the set S such that Z belongs to C such that Z minus A modulus minus Z plus A modulus is equal to 2c. This represents what? This represents hyperbola.
Hyperbola.
Okay, so this मैं इसको इतना express नहीं कर रहा हूँ. You can do the same जो अभी यहाँ steps किए थे. You can do the same steps and then you can find ellipse. अच्छा, another way of looking at it. See, चलो let us do let us just finish this lecture by looking the same expression in a different way. See, we wanted to discuss the nature of the set S, which is given by Z belongs to C, such that Z minus A modulus plus Z plus A modulus is equal to 2C. If I don't solve it, and indirectly, if I want to make certain, you can say, conclusions from this particular thing, what I can do is, see, a little bit of mathematics, you know that from mathematics, you know that there is a triangle inequality. Sorry, there's a triangles inequality which suggests, which gives you this. Okay, this is triangle inequality number 1, and triangle inequality number 2 would be Z1 minus Z2 will always be less than Z1 plus Z2 mod. Okay, these two things, I think it is quite evident, you know already. Okay, now if I want to express 2a modulus, so what is 2a modulus? I can write 2a modulus as Z plus A minus Z minus A. And this will be less than equal to mod of Z plus A plus mod of Z minus A. And what it is equal to? It is equal to 2C. So if I am saying that there are some complex number which satisfies 1. So if there are some complex number which satisfies 1, it implies what? It implies the condition would be equals to 2a modulus should be less than equal to 2c. Okay, which implies mod of a should also be less than equal to c. So if there are complex numbers which satisfy this equation, indeed it is an equation for ellipse, but at times in examination you may be given some option which suggests that does it imply that mod a should be less than equal to c? Yes, it implies that mod a should be less than equal to c. Is that clear? Now suppose some complex numbers z is belonging to this set S, then 2 times Z modulus can be written as modulus of Z plus A plus Z minus A, right? See, 2 times Z is equal to modulus of Z plus A plus Z minus A, right? And this will be less than equal to modulus of Z plus A plus modulus of Z minus A. Is that clear? And it is equal to what? It is equal to 2C. Shikha, is that clear or not? समझ में आ रहा है ऊपर से? Okay. What does it imply? It implies that what is the maximum value of modulus of Z such that Z belongs to S? It is certainly equals to C. See, from here it is quite evident that modulus of 2Z is less than equal to 2C, and it implies that mod Z should be less than equal to Z. So if Z belongs to this set S, then the maximum value of modulus of Z can be C. Is that clear? Yes. And not only this, if Z belongs to S, then the sum of the distance from point A, which is equals to what? Z minus A, and sum of distance from minus A, which is Z plus A, is equal to what? It is equal to C. So if you remember in standard 12th, whenever teacher used to say what is ellipse, ellipse is such a structure whose distance from two focus, the sum of distance from two focus is always equals to constant, and it is always equals to 2 times the length of the semi-minor axis. If you remember, ellipse को कैसे define करोगे? Ellipse is locus of all those points which are at a what is ये दोनों points जानते ना, a and minus a क्या होता था? These are called as the focus. So these are nothing but these are the foci, and the distance of all the points, the sum of the distance is always from the focus is always constant, and it is equals to 2 times length of the, I think, semi-minor axis there, if I'm not wrong. But overall, remember that this is how we define the locus of an ellipse. So indirectly also it was quite evident that we are talking of ellipse, and we actually found out the equation also. So we found that the equation was ellipse, but I'm just trying to make an argument that in exam, if you're not able to solve that also from a little bit of things, understanding also you can do. Is that clear or not clear?
Yes, sir.
ठीक है. ऐसा कौन सा लोकस होता है जहां पर डिस्टेंस, सम ऑफ डिस्टेंस फ्रॉम टू कांस्टेंट पॉइंट इज अ कांस्टेंट, दैट इज एलिप्स ओनली. एलिप्स में क्या होता है, जब आप एलिप्स के पॉइंट्स का क्या लोकस होता है कि एलिप्स के पॉइंट्स का डिस्टेंस फोकस से लें और उनका सम कर दें. इट इज ऑलवेज अ कांस्टेंट. सो दिस इज हाउ यू डिफाइन एन एलिप्स. गो बैक टू योर स्टैंडर्ड 11th. ये सारी चीजें स्टैंडर्ड 11th में तुम्हें आसानी से मिल जाएंगी. I hope it is clear.
Yes, sir.
Now, what about this? You have already found ये सब चीजें, I think, okay. We've already found that Z minus P modulus is equal to Z minus Q modulus. Z minus Q modulus. It implies what? It implies that Z lies on the perpendicular bisector. Z lies on the perpendicular bisector joining points P and Q. Fine. ये तो हो गया. Joining points P and Q. Now, what do you think about this? Z minus P modulus is equals to alpha times Z minus Q modulus. What do you think if P is not equal to Q and let's say alpha lies between 0 and 1? What locus does it represent? Okay, so I'm leaving up this as a homework to you, and I'm giving you a real answer. The answer would be circle. Okay, so this is a homework to you. Try to solve this. The locus of the points or the set of the points which satisfy the equation modulus of Z minus P is equal to alpha times modulus of Z minus Q, such that P is not equal to Q and alpha lies between 0 and 1. It is circle. Just do nothing, just square it up. I'm giving you hint. Hint is nothing but just square both sides. And try to solve. You'll be able to solve it, and this will be nothing but equation of a circle. I hope it is clear. Okay, so from tomorrow we are going to start with. अरे यार इसमें डबल एम आता है कि डबल ओ आता है, ये भूल रहा था हमेशा. So from tomorrow we are going to start with. नहीं, I think double R आता है. So
Single N.
अरे हर बार भूल रहा था. Every time I forget this tomorrow spelling. ठीक है. So tomorrow we are going to start with topology of complex plane. So I hope you might have taken one lecture on already on open set, closed set, compact set, closed set, and all those things. But still, I will try to revise all the concepts in the light of the complex plane. Okay. So this is an important lecture. From here, your complex analysis begins. Till now, I was just refreshing the concepts that you've already studied in your standard 11th. So these are all 11th class things. Okay. Probably you may not have seen it to this extent, but the students who are actually studying for JEE or something actually studied till this level. So I have given you some brief, what you can say, introduction to complex numbers. Don't study too much here. Just think whatever I have taught you. Just think over these lines only, because in exam, whatever exam that you are going to fight now, that is GATE or NET, not direct questions from complex numbers won't come. So don't worry if you don't follow much about it, but at least you should be acquainted with all these concepts. At least you should be knowing that how can I make my way in expressing the locus of a locus that is being hidden in a particular set. So let's say here it is an hyperbola or some ellipse, and all these things. At least you should have some little bit of idea. Otherwise, it's fine. You have to pay a lot amount of attention from topology of complex plane. This will be a one lecture. And from there onwards, we'll start complex analysis. Possibly a lecture or two on sequence and series I would give. Already you know much of the sequence and series, but still a little bit about sequence and series in Z. And then we'll start with mostly complex functions. But before starting complex functions, you should be able to understand what is an open set, what is a connected set, what do you mean by domain of a set, domain set, and all these things. So basically, all these things becomes quite necessary in complex analysis. So I hope things are clear to you. I'll meet you tomorrow. Till then, take care. Bye.